Hello, hello. This video will be going over our Unit 4 Test Prep Part 2. This will be going over sections number 3 and number 4 for our test. There will only be one question of each of these types, but it is still very important that we understand the process of how to solve these. So let's go ahead and look at section 3, which will deal with inequalities. The setup to this will be I'm giving you guys a system of equations, that being 0.5, x plus 3 squared minus 2, and x plus 5. In this situation, we're dealing with these two. So let's go ahead and figure out what part A is saying. Find the solutions for when x plus 5 is equal to 0.5 parentheses x plus 3 squared minus 2. And this is asking for when they're equal. So right now I'm just solving the system of equations. And of course, the solution for my systems happen when my when my equations are equal. That happens at these intersections. So that's why I'm going to bubble those in, because those are going to be my solution points. Now, let's go ahead and figure out what those solutions are. When we've been talking, my solutions happen when my x equals some value. That's what we've been using to find our solutions. So I'm going to count over, and my solution happens when x is equal to negative 5, because that's where my first intersection happens. And my second intersection happens when my x is equal to 1. Okay? So I'm just noting the x values for which my graphs actually meet and are equal to one another, and that's what I'm looking to do for part A. For part B, it asks me to identify the x values for which x plus 5 is less than or equal to 0.5 x plus 3 squared minus 2. So now we're actually trying to compare one to the other and not just set them equal to each other. So at this point, I think it's fairly worth our time to go ahead and figure out which one is this equation and which one is this equation. Which one is equation number 1 and which one is equation number 2. So let's go ahead and see. So first thing I notice about my first equation is that there are a lot more moving parts than my second one. I also notice that I have a power 2, and since it's applied to parentheses, it applies to everything inside this parentheses, which means I'm going to get an x squared. And whenever I have an x squared value, that's going to make a parabola. If you're not able to make all those connections, then perhaps you remember this. This is our vertex form for our parabolas that we saw in Unit 2. So by its complication, by its form, by its power, we should be able to recognize that, hey, this is my parabola. I'm going to label my parabola line number 1. And if you have the highlighters available to you, I would actually absolutely highlight this as my line number 1 to my equation number 1. Secondly, well, by process of elimination, I already know that this is going to be my line number 2, but I also know that just based on its form. It's simple, it's only x plus 5. This is what we would see in Algebra 1. This is linear. This is a basic version of a linear equation. So I'm able to highlight that and denote this as line number 2. So, in other words, this is asking me, identify the values for which line number 1 is less than or equal to, excuse me, it's not asking about line number 1. Let's make sure that we label this correctly. Identify the x values for which line number 2 is less than or equal to line number 1. So let's see where that's the case. I'm looking to see where my line number 1, that's going to be my linear equation, my blue line, is less than my parabola. And let's see. Well, I start, my line number 2 is less than my line number 1. By less than, or I dissected what less than means, this is going to be lower. This is going to be, where is my line number 2 lower than my line number 1? And that's at the very start. And it continues being lesser until I hit this point of intersection. That's why A is so important. It tells us what x values we're actually be considering. So I know that my x values are going to interact with my negative 5. But the question is, when am I lower than my line number 1? Where's my line number 2 lower than my line number 1? And it's at negative 5 and to the left. So the way that I write that out is by saying x is less than or equal to -5. The reason I have the equal to sign is there is because if I start with an equal to sign in my problem, I need to have an equal to sign in my answer. So I'm saying x is less than or equal to -5 is where my blue line is lower than my red line. But of course, this after that, my blue line's on top, my blue line's on top, my blue line's on top, until again my other point of intersection. That's gonna be x and 1 that I'm comparing, and then it's everything to the right of this. Everything to the right gets more positive. So I'm gonna say when x is greater than 1 or equal to 1 is when this happens. So it's -5 and everything to the left, and 1 and everything to the right is where my blue line is lower, is less than my red line. Looking at part C, my order is the same, so I'm still talking about line number 1, excuse me, line number 2 and line number 1. But now I'm saying where is line number 2 greater than line number 1? Where is my linear equation higher, greater than my parabola? And that happens in between. You see this whole area is the space in which my blue line is higher than my red line. Where my line number 2 is greater than my line number 1. And of course, our intersections are going to be very important. So I'm going to set up x to -5. And this happens when my x is greater than -5. So I'm starting at -5. And for my x values that are greater than -5 is when my blue line is above my red line. So I'm going to say x is greater than -5. I just say greater than because I had no equal to in my beginnings. So I don't need to include that. And then I look at my other boundary points. So to the left in this case, it was to the right of this point, and it's to the left of this point that my blue line is greater than my red line. So I'm going to say x is less than 1. And these are my two answers for part C. But if you notice, this encompasses a space, an interval, a space in between two numbers. So when I have a space that's specifically overlapping between two numbers, I can write this out as one interval. That being my beginning point, my end point, my value that I'm talking about, and two less than signs. And if you compare these are saying the same thing. Saying -5 is less than x, -5 is less than x, and x is less than 1, x is less than 1. So if you write either one of these, I would accept as an answer, though this one is probably a little bit more cleaner. So I would recommend you write this in interval notation. Okay? So, our second question in this section is something very similar. We have a parabola, which is going to be this one. So this is going to be line number 1. And this is going to be my line number 2. This is my linear equation, line number 2. Okay? So from there, you're going to decide where they equal. When is one line less than or equal to the other? And when is one greater than the other? So please take a moment to consider this. If you have questions, please let me know and reach out. But based on what we did for the first question, I hope we'll be able to answer our second question. Okay? So with that in mind, let's go ahead and get to our final section. So let me go ahead and model for you what a word problem you're going to encounter is going to look like. So these examples are posted as part of your uh, notes section on section 4.1.4, going over word problems. So check your notes, check the slides that were posted, but the examples were not printed out in our study guide because we had a number of problems we did not get to in our notes. So as far as studying material, we're just going to be using that. Okay. So what we are going to do is we're going to go ahead and break down the problem and try and understand what exactly is being talked about here. So, Gloria is weighing combinations of her meal prep service. Okay, this is just giving context. We're talking about meal prep and service and combining, making some sort of combination, and we're talking about weighing these combinations. Okay? So, our first part says we have 4 meal containers, and 5 snack containers, and those weigh 32 ounces. And then we have 1 meal container, and then 8 snack containers, and those weigh 35 ounces. Question asking us to write and solve a system equations to determine the weight of the meal container and one snack container, of 1 meal container and 1 snack container. So we're supposed to set these up and try to solve how much does 1 meal container weigh and how much does 1 snack container weigh. So that's going to be our goal. So we should be able to make 2 equations out of these 2 sentences that give us information about the situation. If you're ever stuck and not really sure how to proceed, word problems really, really benefit from having a visual component. So I would absolutely just make a image for both of these. So let's go ahead and look at our first sentence here. So it says 4 meal containers. I'm no artist. I'm just making representations to show, hey, I have 1, 2, 3, 4 meal containers and 5 snack containers. So snack, 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 and snack. And they weigh together 32 ounces. And just by putting that visual up, it gives me more of a roadmap of what I need to do in order to make these equations. So my equation is going to be 4 meal containers. So I'm going to write 4m plus 5 snack containers. We'll call that 5s is equal to 32. Okay. And if we do something similar for our second equation, we should get 1 meal container plus 8 snack containers is equal to 35. Okay. So we're just taking what's going on. We are making the information and we are going to make equations out of those. And now we have a system of equations. We have 2 equations that we're going to combine and use to solve so that we could figure out what our variables are actually equal to. Okay. So I have my system. I'm going to go ahead and make it down here. Let me see if I can zoom in, give myself some more room. That much room. Okay. So I have 4m plus 5s, and I have 1m. 1m is the same thing as just saying m, so I'll write m. M plus 8s is equal to 35 equals to 32. Okay, so in order to solve my system equations, I need to make my equations equal, but there's a problem. Right now, I don't have anything that I could make these, I don't have any way to make these equations equal at this point. In my other systems, I have 2 equations where I have y equals, and because both my equations are equal to y, I could then make them equal to each other. But in this case, I have one equation equal to 32, one equation equal to 35. There's no equality between them. There's no overlap as far as what they're equal to. So at this point, I cannot make them equal to each other. So what I need to do is I need to solve for one of my variables. It doesn't matter which one you choose to solve for, but in this case, I'm going to solve for my variable m for both my equations so that I can set them equal to each other. So I'm going to look at my equation number 1, 4m plus 5s is equal to 32, and I'm going to solve for m, which means I want to get m by itself, so I need to get rid of everything around m. First thing I'm going to get rid of is my 5s. So I'm going to minus 5s. And 32 and 5s cannot be combined because I have an s value and no s value. So they're not like terms. So I just have 4m is equal to 32 minus 5s. And then the last thing that's keeping my m from being by itself is dividing by 4. Divide by 4, divide by 4. And my m is equal to 32 minus 5s. all over 4. Okay? So if that's the case, then I am all set. I've solved for m. This equation is resolved. Now I need to do the same thing for my other side. So I'm going to set up m plus 8s equal to 35. And once again, I'm solved for m. This one is a little bit easier because there's nothing attached to my m other than this 8s. So if I'm minus 8s, I get m is equal to 35 minus 8s. And now I have one equation equal to m, two equations equal to m. I am now set up to set my equations equal to one another because now they're both equal to m, and so they are equal to each other. So I'm going to have 35 minus 8s is equal to 32 minus 5s all over 4. And now we are set up exactly like we were in section 2 with our systems of equations. Instead of x, we have s, but essentially we're going through the same steps in solving. So let's remind ourselves what those steps are. I see a fraction. I don't like a fraction. I'm going to get rid of that fraction. In order to cancel with my fraction of dividing by 4, I'm going to multiply by 4 on both sides. And that gives me 140 minus 32s is equal to. Now on this side, I'm not multiplying my 4 in because all I'm doing is canceling here. My times 4 cancels my divide by 4, so I have 32 minus 5s on this side. So with that being said, I'm going to go ahead and try and solve for my s. Right now I have two s's, so let me go ahead and move this s plus 32s over to this plus 32s. And I'm going to get 140 is equal to 32, and that's going to be plus 27s. And if I minus 32, I'm going to get 108 is equal to 27s. I'm solving for s, so I'm getting rid of my 27. I divide, and I'm going to get s is equal to, grab the calculator, and I'm going to do 108 divided by 27, and that's going to equal to 4. So I get the very lovely answer of 4. Now, I am not done because I do know the value of the weight of one snack container, but I do not know the answer for my meal container yet. So what I need to do is I take the information that I know and now use that information to plug in into one of my original equations. I'm going to choose my second one because it looks a little easier to work with. So it's going to be m plus 8 instead of s. I'm going to write 4 is equal to 35. This is going to be m plus 32 is equal to 35. And when I subtract on both sides, I get m is equal to 3. So I know what my meal is worth. I know what my snack weight is worth. And this is how I complete a word problem. So you guys still have in your notes example 3. You guys have in your notes example 4. And here you now have, rather than example 5, you have the exit ticket. I would recommend very much studying how we did example 2 and the exit ticket because this is going to most resemble what's going to be on your test. I think the other two are very good practice, but understanding in depth these two problems are really going to give us a leg up on what's coming up on the test. But with that being said, that is all I have for you this weekend. We have our test in a few days still, so you still have some time. Tutoring on Tuesday. Please come with questions, and I'll be happy to help you. Best of luck. Happy studying.